Hello guys, hello everyone. Good to see you again. Today we're going to continue on the previous video. I did question 1 to 5, and today we're going to do question 6 to 10. And the questions are from Math League Context, grade 5 to 6, and second round. Okay. So let's go to question 6. Let me also make this larger. And question 6, there you go. Okay, so I'm going to read the question. In the following graph, is it possible to connect the 18 consecutive points with a closed non-intersecting line such that each line segment connects a pair of numbers as follows? 18 to 1, and then n to plus n and n plus 1 to the end. Well, basically what it says, is it possible to connect number 1 to 2, 2 to 3, 4, and then you go to 5, and then you go to 6 and 7, 8, and all the way to later to 18, and from 18 to 1. And it's going to be a closed loop. But when you do, if you intersect, well, it's kind of like a loop. You say, no, it's not possible. But is it possible to connect all of these, okay, make a loop, a closed loop, without intersecting? So your shape probably would be something like this, but you don't cross, okay? So the answer is, I want you to try. I'll show you. You could try it yourself. The answer is yes. Okay, it's going to take a lot of time, so I'm not going to do it here. But I've done it before. The picture is going to be something like this. Okay, you could pause the video, check it for yourself. The answer is yes. The reason I made the last one from 17 to 18 blue, because it's just, I want it to be visually easier for you to see everything. Okay, so that's a closed loop, and there is no intersection. Okay. But here, the question will also ask you something general. It says generally, more generally. Is it possible for any number of points, not just 18? What if they give us 1,000 or 10,000? Is it still possible? What do you think? I would say, yes, it is possible. And my reasoning is like this. You just have to connect all these points, right? 1, 2, 3, 4, 5, 6, and then they put it here. You see, you would connect all of these, right? That's a loop. Now, you want to make, where can you put the next point so that I have to cross my line? If you put it inside, so I'll go from this one to here. If you put it again inside, well, I will go from here to here. If you put it outside, well, we go here to here. And then you put it inside, well, I have to go back and to that one. Okay, it's always possible. Okay, but you have to, if you put it too messy, okay, yeah, well, we can't do it. But as long as you keep it clean, the answer is yes. Okay, we could actually connect any number of points, okay, this way. So I would say yes. Okay, question 7. So let me get the question again. Okay. So understanding this is key. You have an unlimited supply of colored beads, either orange or blue. You may take any number of beads and orange and arrange them in a string. Let us call any group of consecutive beads in such string a word. That's just that's a word. The length of a word is a number of beads in it. It's not important. A word of length 2 is a couplet. There are 4 possible couplets, orange, orange, of course, like all the possibilities. It's going to be orange, orange, 1 orange here, 2, the other orange here, and no orange. And so these are going to be the 4 possibilities here. I'm going to write them here. Okay. Now, what is the question? And then at most, how many beads can a 2-color string if no couplet? It appears more than once. So let's read it more slowly. Okay. So I wrote all of it. Then at most, how many beads can a 2-color string contain if no couplet in it appears more than once? For example, in the string as follows, the orange, orange couplet. So for example, this one is not valid. This one is not okay. Why isn't it okay? Because you see this couplet over here is being repeated 2 times. Why? These 2 will make the couplet. These 2 also make it. So we have repeated 2 times. So that's forbidden. You cannot do this. And then, moreover, a word of length 3 is a triplet. Okay. There was one other question here. Okay, let's now answer this. Then at most, how many beads can a 2-color string contain? Okay, we want to make it as large as possible. Okay. Let's see here. I have to create some space. Okay, we want to make it, I could put 2 orange here. Let's just start like this. And I could put 2 blues here, right? So I have used orange and blue. I would put 1 orange here. Okay. And I cannot add any other blues here, can I? Blue, orange. Let's see if I have used all of them. Orange and orange. This couplet has been used. Orange and blue. These 2 together. So this one has also been used. Blue and orange. Okay, so I've used all of them. That's the maximum. I've also done, okay. This question before, let's check it. Yes. So for this question, the max will be 5. Okay. Now let's continue on actually the main question, which is going to be kind of like the previous one, but this time it's asking us about triplets. Okay, how many blues and oranges with 2 colors? How many triplets can we do? Well, the answer is going to be these. Maybe we have 3 blues. Okay. Or maybe we have 1 blue. If we have 1 blue is here, 1 blue is here, 1 blue is here. And what if we have 2 blues? 2 blues could be here. 2 blues could be here and here. 2 blues could be here and here. And then I'm going to add the oranges to the picture. This is going to be 1 blue again, 1 blue here, 1 blue here. 2 blues, 2 blues, 2 blues. And here we have, that's a bad picture. Wait a second, let me correct it. Okay, we could also have orange and orange and orange. Okay, so 8. We have 8. Then how many triplets are possible? 8. And at most, how many beads can a 2-color string contain if no triplet in it appears more than once? So let me see if I can make the maximum. So it's going to be, let's try 1 3 here and 1 3 here. Okay, if I put it here, how many couplets I've used? Obviously, I've used this. I've used this. These 3 together is orange, blue, blue. Where's orange, blue, blue? Okay. I've used this. And 2 oranges and 1 blue. Okay, 2 oranges and 1 blue. I've used this. Okay, have I used anything else? No. Okay, so we still could add to it. Can I add 2 oranges to this? Now, if I add 2 oranges, you get 2 blue and 1 orange. Bang. And 1 blue and 2 oranges. Okay. Now let's see. There are more shapes, okay, that we haven't used, right? Okay, that's pretty good. Orange, orange, blue. I can't add this. How about this? No, if I add this blue over here, it's impossible. Okay. Blue, orange, blue. Okay. Is this the maximum? No, I guess not. Still possible to add more to it. Definitely, but can I add this here? No. Can I add a blue here? Blue, orange, orange, no. Okay. Maybe would add a blue in between. But the question would be a little different now. Blue, blue, orange. Okay, blue, orange, blue. And orange, blue, orange. Well, I think that must be the maximum. Okay. 3, 6, 9. I have done this previously. Okay, so we could also add another to here. This way, the maximum, and we have used each one once. Okay, let's check. Blue, orange, orange. We have used it here. Okay, orange, blue, orange. This one. And 2 blues and orange between them. These 3 will be here. And we haven't used any of them 2 times. So in this case, the maximum will be 10 beads. Previously it was 5, now it's 10. Okay, that's the answer. Let's go question 8. So question 8, if you have 5 different colors of paint and you only need to paint the eyes, nose, and the mouth of the Halloween mask, in how many different ways can you paint the Halloween mask? If you make the nose, mouth, and each of the 2 eyes different colors. So I think most of you can answer this question. If you are doing the second round, we have 5 colors, okay, and we have 4 things to color. So we have 4 places. One of them for the mouth, for the nose, left eye, and right eye. And we have, well, we have 5 colors, but here it says if you have 5 different colors and you only need to paint the eyes, nose, and mouth, can you paint the Halloween? If you, okay, so here it says a different color each time, right? I was looking for this. So to mouth, imagine we want to start coloring from the mouth. We have 4 possibilities. We use one of the colors. So for nose, we have 1 less. For the left eye, we have 1 less. Then the right eye, we have 2. We multiply all of them, 120. Very straightforward, isn't it? Okay, but it's good. You could check your answer with mine, so we get certain if the question's right. Okay, now the next one, let's read it in a 6x6 chart. Okay, you can see it. You're allowed to paint any column or any row in the chart. You can select any row or column and flip the colors of all the squares within that line. Example operation where you select the first row and flip the colors. Okay, so it was like this. All these whites become blue, and this blue becomes white. So that's how we go from the first one to the second one. At least how many times you have to flip a row in order to have exactly 24 blue squares. So here, one thing to pay attention to, how many times you have to flip a row, just the rows, not the columns. Okay. So once we get everything blue, well, obviously we could do this. Let's go. Do we have something all blue? So this one, all of these will be blue. Then these blue, these blue, these blue, these blue. And the last one, all of these blue, but this one is white. And is there a way to get rid of this? Now, what if we want to flip all these colors of this one? All the blues becomes white, and this one will be blue. Is there a way? Can we continue? Can we change this? Well, I tried, I couldn't do it. So I will go with this option. It's impossible to have exactly 24 blue squares. If you think different than this, please let me know in the comments. Okay, question 10. Probably a lot of you have a problem understanding the question, okay? So let's try to understand it first, okay? A cube has 3 fourfold axes of rotational symmetry, where one is shown below as the red line. Okay. So it has 3. First of all, let's see why 3. It's because we're going from the middle of these two sides, and from the middle of these, we go all the way to here, and then we continue from here. Okay, and then we have another one, which going from here, we go to this point, and then we continue all the way coming out of this thing. Okay, so we have 3 of these, but why does it say fourfold? Okay, so that means to go back to the beginning, we'll have to go 490 degrees to make it 360 degrees. Does it make sense? Well, probably not, but I'll show you how. We're gonna watch a video together. So let's see it here. I'm gonna show you a video. You could watch it yourself too. I found it on YouTube. Just to understand what the question asks for.
Now, consider this cube. When we rotate the cube about this axis for 360 degrees, we can see that the cube matches itself for 1, 2, 3, 4 times.
Okay, that was why we call it fourfold. It rotates 4 times to get back to the original point.
With this, we can say that this axis is the axis of rotational symmetry of order 4. Now, this cube has more than one axis of rotational symmetry. Let's explore them one by one. This is the second axis of rotational symmetry. When we rotate the cube about this axis, we can see that the cube matches itself for
1.
1,
Mhm.
2, 3, 4 times.
Okay, we have 3 of these 4-fold rotations. And here, we're not gonna watch all the video together, just one thing. Because
For the 6th axis, this axis has the order of 1, 2, 3.
okay, so that was a 3-fold axis, because each time we'll go 120 degrees. And the line, the axis was being like this. Okay. So you can watch the video yourself. I'm not going to give you the answer. Watch it, because this video also gives away the answer. All you have to do is watch this video to the end. I'm sure you can find a video. So watch it for yourself. And that's all the questions 5 to 10. Please, if you watch this, let me know if it's useful. Because I don't really know how many people are looking for this test, if it's useful or not. If it is, if you're looking for this, let me know. Okay, that's enough for this lesson. Take care and see you next time.